Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is arithmetic progression properties. In this video, we will discuss about some of the important properties of arithmetic progression, which we will be frequently using in solving different types of problems on arithmetical progress. Okay, let us start with the first property. Here is the first property. If a constant quantity is added to or subtracted from each term of an arithmetic progression, then the resulting terms of the sequence are also in arithmetic progression with same common difference. This is the first property. Now let us see the proof of this property. Let us consider some terms. Let that be A1, A2, A3, A4 and so many. Let this set of terms be an arithmetic progression with common difference D. Again, let k be a fixed constant quantity. Now let us add this k, the fixed constant quantity, with each term of this arithmetic progression. Then the resulting sequence would be? Hope you are clear with this step. I am assuming a set of arithmetic progression with a common difference d and taking a fixed constant quantity and then I am adding the same constant quantity with each of the term, so the resulting would be this. Now let us assume Bn. Bn is nothing but an plus k, where n is 1, 2, 3, 4, all natural numbers. Then the new subsequence, the sequence is b1, b2, b3, b4. Now let us find what is bn plus 1 minus bn. Bn plus 1 minus bn would be an plus 1 plus k minus an plus k. Now distribute the sign, so we will get k will get cancelled out and the resulting would be an plus 1 minus an, which is nothing but the common difference. Am I right? So that is equal to d for all natural numbers. And we know that an is a sequence with a common difference d. Therefore, the new sequence we get after adding a constant quantity k to each term of the arithmetic progression is also an arithmetic progression with a common difference d. Hope you are clear with this property. Hope you are clear with the statement and proof of the property 1. To get the clear concept of this property 1, I'll give you some more explanation by adding a constant quantity and by subtracting a constant quantity. Let us assume a be the first term and d be the common difference of an arithmetic progression. Then the arithmetic progression would be a plus d, a plus 2d, it keeps on adding. Now let us see what will happen by adding a constant quantity. If a constant quantity k is added to each term of this arithmetic progression, then we will get a plus k. I am just adding the same k with each of the term in this arithmetic progression. First term of this sequence is a plus k. And the common difference of this sequence would be just subtract these two, a plus d plus k minus a plus k. So the common difference would be d. Am I right? Therefore, the terms of this sequence form an arithmetic progression. Hope you are clear with this concept now. So you can say that hence if a constant quantity be added to each term of an arithmetic progression, the resulting terms are also in the arithmetic progression with same common difference. Okay, let me show you the same concept by subtracting a constant quantity. Let me take the same arithmetic progression. If a constant quantity k is subtracted from each term of this arithmetic progression, then we will get a minus k, a plus d minus k, a plus 2d minus k, a plus 3d minus k, it keeps on going. So first term of this sequence is a minus k. And what about the common difference? Let's find the common difference by subtracting second term and first term. A plus d minus k minus a minus k. If you distribute the sign, you will get these terms cancelled. D. Okay. So a and k gets cancelled out and you will be left over with d. Therefore, the terms of this sequence form an arithmetic progression. So you can conclude that if a constant quantity be subtracted from each term of an arithmetic progression, the resulting terms are also in arithmetic progression with the same common difference. So hope you're clear with first property by adding a constant quantity and by subtracting a constant quantity. You can try some numbers. You can take any arithmetic progression and a constant k and try adding the same constant quantity. The resulting would also be an arithmetic progression with the same common difference. You can try for both addition and subtracting. You can let me know your answers, let me know your problems, the examples that you're discussing in my comment section. If you have any query regarding this first property, please let me know. Please make sure that you're clear with this property because we will be using this concept while solving the problems. Okay, now let us move on to the second property. Here is the second property. It states that if each term of an arithmetic progression is multiplied or divided by a non-zero constant quantity, then the resulting sequence form an arithmetic progression. First property dealt with addition and subtraction. Second property is dealing with multiplication and division. Please make sure that you are using a number which is a non-zero constant quantity. Okay, even if you are dividing or multiplying the arithmetic progression by a non-zero constant quantity, the resulting sequence would also form an arithmetic progression. Let us see the proof for this property first. Let us first assume an arithmetic progression with a common difference d. Same as the previous property, again here we are going to assume some constant k. K is a fixed non-zero constant quantity here. First, let us multiply this non-zero constant quantity with each of the terms in this arithmetic progression. So the resulting would be, let these terms be named as B1, B2, B3, B4. So this sequence, after multiplying each of the term of this given arithmetic progression by a constant non-zero quantity, we will get these terms. So let this be B1, B2, B3, B4. Just to make our writing work simpler, I am assuming these numbers, these terms as B1, B2 to Bn. Now, let us find the difference between Bn plus 1 minus Bn. So, the difference between these two terms would be An plus 1k minus Ank. You can see that k is the common factor between these two. So, taking that out, you will get n plus 1 minus Ank. We know that this is nothing but the common difference d for all natural numbers. That's it for this property. Therefore, you can say that the new sequence we get after multiplying a non-zero constant quantity k to each term of the arithmetic progression is also an arithmetic progression with a common difference dk. So, to get the clear concept of this property too, I can give you some more explanation on multiplying a constant quantity and by dividing by a constant quantity separately. For the operations multiplication and division, please make sure that you take a constant quantity which is a non-zero one. Okay. Please consider this arithmetic progression. If a non-zero constant quantity k, which is not equal to 0, is multiplied by each term of this arithmetic progression, we will get. So here the first term of this sequence is ak. And what is the common difference? If you subtract these two, you can find the common difference. Common difference here is ak plus dk minus ak would give you dk. Therefore, the terms of this sequence will form an arithmetic progression. Therefore, you can conclude that if a non-zero constant quantity is multiplied by each term of the arithmetic progression, the resulting terms will also be in the arithmetic progression. For this, you have to identify the first term and check the common difference. That would help you. Hope you are clear with this concept now. Okay, let me show you the same concept by dividing a constant quantity. Consider the same arithmetic progression a plus da plus 2d. If a non-zero constant quantity k, which is not equal to 0, is divided by each term of this arithmetic progression, then we will get. So this is the resulting sequence. First term is a over k. And what would be the common difference? Common difference, if you subtract these two, you will get d over k. Am I right? Therefore, the terms of this sequence form an arithmetic progression. So you can conclude that if a non-zero constant quantity be divided by each term of an arithmetic progression, the resulting terms are also in arithmetic progression only. Hope you are clear with first two properties. In case if you get any query regarding these two properties, please let me know. You can assume some numbers for a and d and try the same concept, and let me know your results in the comment section. See you in the next